Okay. All right, on to the next thing here. So the next thing I want to talk about is section 1.4, vector addition. We're trying this out. I don't know, maybe you like me singing and dancing more in front of the whiteboard. Sometimes I like that more. I don't know. So vector addition. So let's say we have a vector u, and then we got a vector v. And so we could say, we could give them some names. So given u, let's say it has components 5, 3, and then v has components 2, -4. And so if I'm adding them, I want to see them go, so this one goes tail to head, but what you're going to hear me say is head to tail. See how it points at the tail? So it's kind of like you're following the leader, right? Go here, then go here, you're taking directions. And so the resultant vector, and that's what we call this right here. This is u, vector u plus v. This is what we call the resultant vector. Wish I had better handwriting on here, but this is what you're getting today. Okay. And so the resultant vector, you know, I could literally add vector u with vector v, and I can just add the components. So it's 7, -1. Now I probably didn't draw this on a situation that well, but so you can see there's a total of 5 plus 2 movement in the x, and then for the y, there's 3 movement in the y, and then -4 movements in the y, which result in a total of -1 y movements. So if I had to draw this, let's see, I'd probably draw this system a little bit more like that, maybe 5, 3, maybe. Yeah, that may make more sense. Now the blue one's going down, and that kind of makes a little bit more sense. So, okay. Well, vector addition. Maybe what I can do. Okay. Well, I'm just going to do a new page. So let's do vector subtraction. Real quick here. So, yeah, okay. So let's say I have vector u again. Let's see, I'll try and use the same ones maybe as last time here. On the other page, I'm just going to rewrite them real quick. There's vector u and vector v. We'll say vector v is 2, -4 again. Okay, let me see if I can't just at least make that part smaller. Okay, and so I have u, which is 5, 3. So let me try and draw that here. So that's kind of like that, 5, 3. Okay, and then I have vector v. Now I'm going to draw vector v a little bit differently this time. I'm going to draw it coming out of there. And so we want vector v minus u. So, or I could maybe, you know what, I'm going to add on here. So now I have colors, so I'm going to draw this vector right here. And so what is the name of this vector, right? So I'll call it vector question mark for the time being. And so I do know from vector addition, because I never really thought about vector subtraction. I just thought, well, I'm adding the negative vector, right? And so I know that vector u plus the question mark vector is equal to vector v because they take me to that position, right? So vector u plus vector question mark, that is not a proper vector name. I should have maybe called it George or something, I don't know, is equal to vector v. So this plus this is equal to this because they go to the same point in space. So what we can do is, it turns out, is you can subtract vectors like you do in algebra. So I'm going to subtract vector u from both sides. So now my vector question mark is in fact equal to vector v minus u. So we call this is called the displacement vector. And I think the original picture might sort of give some sense to maybe why that is. So because we're kind of thinking about it as sort of, if ship U was going this way, ship V is going this way, and if we think about displacement as like a distance between them, the magnitude of the displacement vector would be the distance between those ships after a certain time interval or something like that. So to me, that's why displacement vector, which it's often called, is that way. So anyway, let's see. How else do I remember? Do you remember it? So okay. Head minus tail. Let's see. How do I explain that on an iPad? Okay, well, I might come back to that statement for you guys. So let's go on to an example that has some other goodies in it. So let's come up with some situations here. So given points A, which is the point 10, 2, and point B, which is 7, 13, find vector AB. This makes sense. Now, if you have points, the convention right here is to say the vector going from point A to point B is vector AB. Vector BA, which was my favorite A-Team character, it was Mr. T, stood for bad attitude. He was great. BA is negative AB. So if you have these 2 points, I just want to make a comment on this because I think it's important. So negative AB is equivalent to BA. Oh, yeah. Okay, so we want to find our goal here, because I don't have a question stated yet. So I want to find vector AB. Wait, I just wrote that. Oh my gosh. I'm sorry. Oy. So, just as like a demonstration. Now, there's another situation here I want to give you guys. So let me just draw a quick coordinate axis. It's not going to be pretty. For whatever reason, this drawing program or this virtual whiteboard, it just doesn't have like an arrow. I was kind of expecting it to, but anyway. So let me add this comment. Points are more or less position vectors. and a position vector starts at the origin. That is, its tail, the one without the arrowhead, is at the origin. So I have vector 10, 2 here. So what I'm going to do is I need to make sure I get up to 10 on this one. Let's see, on the x. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13. So let's see, 13, 12, 11. Let's mark my 10 spot. I'm going to go up here a ways too. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So if I want to draw vector A, I can use colors. Vector A is 10, 2, so that point is here. But I can think of that, not very straight, as a position vector. And I can think of this one as vector O, A. So O for origin to A. And then I can draw in another color. I can draw point B is, let's see, it's 7, 13. So 1, 2, 3, 4, 5, 6, 7. And I think 13 is the top one here. And so this vector is OB. And I want vector, let's see, green. I like this green a lot. I want vector going from point A to point B, because this would, in effect, be vector AB. Now, so how I think about, I kind of oversimplify it a little bit. So let me draw this out first. And so what I'm saying is OA plus AB, if I look at my sort of vector paths, is equal to OB, right? So if I want vector AB, right here, that's my goal, I can subtract vector OA. Okay. So we're going to subtract vector OA. And so AB is equal to OB minus OA. Not very well written. And so you can see that. So what we can do then is we know that AB is going to be this. So OB is basically the point B written as a vector, 7, 13. And then OA is point A written as a vector because it's a position vector. And that's 10, 2, if I can fit it on this screen. Okay. So I know the point vector AB, point vector AB, that's confusing. The vector AB is negative 3, 11. There we go. Now, you're probably like, Mr. Paulson, that seems like a lot of work. Well, kind of is. Okay. So, but let me sort of give you another way to think about it. Let's look at what we did here. I'm going to use yellow here to point this out. So we want vector AB, right? We want vector AB. And in the notation, it's telling you some stuff. That's the head. That's the tail we want, right? So your tail is located at point A, and the head is located at point B. And what did we do? We took and we did head minus tail. So if I want a vector between 2 points, I always am thinking about that. I'm doing head minus tail because a vector is a change in position on a Cartesian plane or in space. And so you can get that. If you know where you are and you subtract the position where you came from, what's left is the change in your original position to your new position. So that is my thought on that. So I'm going to stop this one for now, and